I don't know what's causing the clicking sound. I hope it's not too bad. Can you hear me well? Not really. Okay. Thank you. Okay. Okay, thank you very much for having me here today. I'm very happy to be here, although I must say that when I was first asked to give this presentation, I thought somebody made a mistake. Because I'm not actually an ecosystem modeler, and I'm not really a social scientist either. My background is really computer science and philosophy, and my specialty are computerized decision tools, knowledge-based decision tools, which are a different beast from end-to-end ecosystem models. But then, when I started to think about this, I thought, well, the lessons that are to be learned about my kind of models and how to integrate more social science information into them are pretty similar, I think, to lessons, or can be applied to ecosystem models. But I'll let you be the judge of that. So let's go right into it and see. So the interactions between humans and the oceans have a long tradition. And as a result of that, there is now no marine ecosystem that is free of human impacts. That's cause for concern. But equally concerning is the fact that the changes in these ecosystems affect human communities in often devastating ways. We've heard a little bit about that, and there's a lot written about that, so we're all aware of it. So natural sciences really help us understand how human and natural impacts change ecosystems, and social sciences help us understand how the consequences of these changes affect people. But what we don't pay enough attention to yet are what the feedback loops are, how these effects sort of iteratively interdependent to one another, something that Ika sort of alluded to already. And the reason why we can't really do that yet is, or not so much, is because natural scientists tend to not really consider social drivers of change, and the social scientists don't really consider natural drivers of change, like our acidifying oceans or the changes in temperature regimes and how that affects availability of fish, for example, for fishing communities. So we need to consider these iterative interdependencies more, pay more attention to these feedback loops, and of course, within the marine sciences, modeling and scenarios are very important, very central to that. So we need to, or we want to, integrate more social science information into those models. But that comes with a set of challenges that's very particular to that. So let's have a look at these challenges. So the first, I've got it kind of down to 3. I'm sure you could make a much longer list, but I think those are, in my opinion, the key challenges. So the first one is that models require measurement. That's absolutely fine from a natural science perspective, because measurement, and with measurement scales, are central to natural science. Scale is also very important in the social sciences, because the interaction between people and the interaction between people and their environment happens at different social, geographical, and temporal scales. So, for example, if you think about households are embedded in communities, right? Or we could think about fisheries management from a provincial perspective. We can also think of it from a national perspective. We can think about individual owner-operated fishing enterprises, or bigger fishing companies, or supranational organizations, right? So those are different scales, but in social science, scales are very rarely specifically measured. And that makes it quite challenging to combine the quantitative analysis of natural science with the qualitative analysis of social science. But qualitative analysis in the social sciences is a more productive way to think about such things as aesthetic values, or cultural values, or power. Very important concepts in the natural sciences. So you can see that's all quite challenging. The next key challenge is that models involve value judgments, always. Doesn't matter whether we talk about natural science information or social science information. As Iko has pointed out, models have to be useful. They have to help us cut through the complexity so we can understand how processes work, etc. So that means we have to decide which variables go in and which variables we leave out. What's important, what's unimportant, that's a value decision. That's also exactly the reason why we have to be very careful about predictive modeling and applying it to societies, human societies, because inevitably there will be variables that are not included. And then my third key challenge is that models have power. They create, or they can create, governable objects for management, right? So if you just think about how the fisheries management tradition has, for the longest time, considered the interactions between people in the ocean as an economic interaction. And a key reason, I think, for that is because fisheries science and fisheries economics share compatible modeling practices. And it has led to a situation where now the behaviors, the social organizations that are being, that we pay attention to from a fisheries management perspective are mainly the fishing companies and their fishing fleets. And that renders other things invisible. The people that work on the boats, the people that work in the fish factories, the people that live in the coastal communities. That's a mismatch of scale. It's a particular lens that has been used for the longest time. And it's a mismatch that has haunted small-scale fisheries for over a century. And this performative power that models have is not just an unintended side effect. It really is something that's inherent to modeling and that we have to be very cautious about as modelers. But nonetheless, I think, agree with a point that Iko has made. I think integrated modeling is a great opportunity. It's a great opportunity for collaboration. It's a great opportunity, particularly for interdisciplinary collaboration. But it means that we have to turn these challenges into opportunities. Now, how can we do that? And I would suggest that there are 4 key questions. And if we ask those, we might be a long way along the way. So, the first key question is we need to ask ourselves what kind of mismatches of scale are hidden behind our assumptions. Modeling should always involve collaboration. It shouldn't be, but no multidisciplinary model should be built by just one person alone. It always involves or should involve conversations with the experts. And that means there is a rigorous thinking through and that we need to make our assumptions explicit. And from a computer science perspective, that's just good. That's nothing new. That's just good modeling practice. But we can use this as an opportunity to also look for scale mismatches and try and make those explicit. And I will give you an example in a minute. And then the next question that we need to ask, as Iko has pointed out, is what is the model supposed to do? It seems simplistic, but we need to remember models are tools, and tools are always built for a specific purpose. And if you use the wrong tool for the wrong purpose, the wheels fall off, right? I mean, then our results are unsatisfactory at best. So we need to keep always the purpose of our model in mind. And then the third, very important question that we need to ask is, what's at stake here? Whose interests are represented in the model? Whose interests fall by the wayside? Who's losing currently, and who's benefiting, and who will be losing and who will be benefiting from the way that we design our model? And that brings me to the last question, and that is to ask, does our model actually do what we designed it to do? So even though we know what the purpose of our model is, even though we might have identified what's at stake, we have to continuously keep asking that question, make sure we're measuring the right kind of things for what we want to do. So I would like to delve a little deeper into these questions, drawing from some case studies on knowledge-based decision tools that I developed for fisheries management in the Benguela region. So knowledge-based systems are really computer programs designed for intelligent problem solving. So they're always focus or address a specific but complex question. And there are kind of two parts to it. So there is a knowledge representation in there, facts about the world, and then a way to relate these facts and draw conclusions. That's the inference engine. And in the case of the knowledge-based systems for fisheries management that we built in the Benguela at University of Cape Town at the Marine Research Institute, we used dependency networks to represent our knowledge, or sometimes we refer to them as value trees. So we have increasingly more complex statements about the world, and then fuzzy logic to link them and draw conclusions. It's a bit like your washing machine. So the first such prototype that we built was a knowledge-based system for the small pelagic fishery, particularly focusing on sardine. And I did this together with colleagues at University of Cape Town, so Astrid Joe, who's here, and Colleen Maloney and others. And the specific yet very complex question that this model aimed to address was whether the management of the South African sardine fishery is effectively implementing an ecosystem-based approach. And in order to build this model, we talked in the first instance with fisheries scientists and fisheries managers, people who knew the ecosystem really well, people who knew the issues around the fishery really well. And then in order to be able to represent the sort of social dimension of this fishery, we drew from a report of a very important stakeholder workshop that had been conducted just before we started this work. And when I talk you through the knowledge representations now, I will only focus on that human dimension, because there's simply not enough time to show you all aspects of the model. So to get back to our first key question, what mismatches of scale are hidden behind our assumptions? So when we built the first prototype, we had about 5 input variables for human dimensions. And we were focusing on 2 key aspects: economic sustainability of the fishery and socioeconomic benefits for the communities. And we specifically built in explicitly the communities because we were very aware of that key mismatch that we mentioned earlier, and we wanted to put emphasis on the communities in there to overcome that bias towards the fishing companies. But then when we looked more critically at our model, we saw it was actually really simplistic, and it still fell prey to 2 assumptions, or there were 2 assumptions at work here that fell prey to that key mismatch, and that is that the well-being of those communities was directly linked to the profitability of the industry, and that we could reduce that dimension, that human social dimension there, to employment in the fishery and how it affected the communities. So even though we really tried to get over that mismatch, we kind of still built it in there. So we knew we had to do something about that, which takes us to the next key question: what's the model supposed to do? So we involved social scientists that worked in South Africa and were very familiar with the coastal communities as well as the fishery. And they helped us build a much more detailed representation of that human dimension. So you see that human well-being category is now broken down into 3 categories: industry well-being, community well-being, and new entrants into the fishery. And then the community well-being component was divided into 3 subcomponents: so benefits from small and medium enterprises, employment in industry, and social benefits. Now what's interesting here is that the benefits from small, medium enterprises and the social benefits were, let's start with the one first. So the benefits from small and medium enterprises were something the social scientists were really keen for us to have included in our model, because they saw those as mechanisms to recreate small-scale fisheries activities in those coastal communities based on a fishery that had become largely industrial. But there were hardly any such medium businesses at the time based on products from this particular fishery. And then the social benefits, that category is based on the assumption that exploiting a natural resource is a privilege, and that those who are given the right to do that should give something back to the communities. So if you think about it, those were really two attempts to inject policy directions into this model. So it was no longer just about representing in that model the social dimension. Our model had become an agent for change. So that shows why it's important to keep asking, what's the model supposed to do? And that takes us to the next question, which is, what's at stake here? So this is the final version of the prototype that we eventually published. And you can see, in terms of the stakes, industry well-being, community well-being, and the well-being of new entrants, those are the three key interests that are represented in the model. But when you look at community well-being, that SMME component is no longer there. And we had quite a few discussions around this, and other things, of course, but one key criticism against including the small-medium enterprise component was that such small and medium enterprises would hardly be based solely on products from one fishery. So how could we use it to evaluate that particular fishery? Now, if you think from an EAF perspective, from an ecological perspective, an analysis based on single fisheries makes no ecological sense. If you use an appropriate social scale, like communities, it doesn't make sense either, because communities hardly ever are just dependent on one fishery, right? But because traditionally we'd been so used to focusing on those 5 companies that controlled that particular sector, we kind of got stuck in that single fishery approach, even though we tried to model an ecosystem approach to fisheries. Isn't that interesting? I think it is. And it takes us to the next question, and that is, does our model do what we designed it to do? And here I just wanted to remind you, I didn't put it in a slide, but you know how central the notion of well-being is to ecosystem-based management approaches of fisheries. So the assumption behind that is that fisheries management should really aim for ecological well-being and human well-being. But what is well-being? Is not a clearly defined notion at all. There's a huge body on literature on that. And equally, a big debate about whether we can reduce well-being to measurable indicators. So this is not a question that I want to find an answer to here. I'm just saying it's an open question. So if we design our model to measure well-being in the fishery, can it actually do that? So I want to illustrate this with a different case study, and this time go to Namibia, and there we built a similar knowledge-based system for the demersal hake fishery, really along similar lines from a technical perspective, and the question was again whether fisheries management was successfully implementing an ecosystem approach. But this time we worked directly, so it's Astrid, myself, and a social anthropologist. So now we had social science research happening directly in parallel with the development of the model. So Kelsey Draper, the social anthropologist, spent several years in Walvis Bay. I lived in Walvis Bay for several years, and that's where the fishery is really located. And we used various methods to really get at what is well-being in this fishing town? What is well-being to people associated with this fishery, or just people that live in this particular fishing town, to which that for which that fishery is really very important. So when we initially tried to conceptualize our understanding of human well-being in the context of the Namibian hake fishery, based on all the research that we had done, we had a really broad conceptualization. And we quickly realized that there was no way we could find indicators for all these elements that would satisfy the criteria of being measurable and having data. So we had to regroup. So we went back to thinking about what does our model need to do and what's at stake here. And through our research, we knew that although there's a lot of good stuff that can be said about the management of the Namibian fisheries, the hake fishery does fall short of quite a few of the ecosystem approach to fisheries ideals. So we knew that what we wanted to do with our model was somehow create a vision for what an EAF for this fishery could look like. And we also, through the research and through talking to numerous people in the town and in the fishery, we knew that there were really drastic issues around employment in that fishery. So it's a highly industrial fishery, and one of the key objectives from the perspective of management was really to make many Namibians, all Namibians, benefit from this resource and from this fishery. And the number one way to achieve that was through employment. But turns out, wasn't all that glorious because the wages were far too low to cover the cost of living in Walvis Bay. There's serious issues around housing. Most of the people live in shacks. Serious issues around hygiene and safety attached to that. There's a labor broker system, which is highly unjust. So there were all sorts of really important issues that the workers face in this fishery. So we really need to make workers and their issues more visible and tie them to management objectives so they become the responsibility of fisheries management, because right now the fishery is managed at the rights holders level. So fisheries management only concerns itself with the distribution of quotas to rights holders. So this is how we finally integrated some key indicators into this model, and it turned out that even though we reduced our focus quite a lot and really just focused on the plight of the workers, predominantly there was still a lot of indicators for which we couldn't find data. They were theoretically be measurable, but we couldn't have data for it. So it was even smaller. The breadth was even narrower than what we would have liked. But we were quite satisfied that it was better than before. So it had at least some key indicators in there that helped tying social issues in the workforce to fisheries management. But what it doesn't do is it does not measure all aspects of human well-being. But it doesn't have to. That's the point. It doesn't have to. So what's the conclusion of all this is integrating social science information into computer models is certainly difficult, but it is possible. And more than that, it gives us opportunities for collaboration and to really think about the iterative feedback loops between the social and the ecological side of the marine ecosystem. But we have to remember that models have a certain power. We have to be very aware of that. And quantification works in some contexts, but not in all contexts. So quantifying things and being able to put them in the model is a means to an end. It's not the end in itself. But we need to be if we are more explicit about that hidden power that models have, we can utilize it. We can utilize it to influence and direct the way we and decision makers think about fisheries management and ocean management. And it also can bring social scientists and natural scientists closer together. And that's a good thing, isn't it? Thank you.
Thank you very much, Barbara. Time for a question. Francisco. Go first.
Yeah, thank you for the talk. Francisco Chavez from the Monterey Bay Aquarium Research Institute. My question was more something about what was at stake, and you didn't seem to have tourism in that. And this is just an example for something that's happened to us locally. there was a rich bonanza of whales very close to our institute. We could see them out of our window. And we discovered that what the whales had discovered a little while ago, that there was an abundance of anchovies there. And once the fishermen found that same bonanza and started to take them, the whale watching community complained that that was why the whales had left and they were losing their revenue. And I was just curious if that's something that happens in other parts of the world, or is it just something that happens in California, and do we need to take those types of things into account? Thank you.
Yeah, I suppose it does. It depends on the fishery. I mean, what just comes to my mind spontaneously is that with the small pelagic fishery and the decline in small pelagic fish in South Africa, that does, of course, impact similar tourism businesses, the penguins, etc. But it didn't come up as a huge issue with respect to our work.
Another last question, Cindy. You were. Cindy.
Barbara, that was a terrific talk. I think it represents the best of IMBER. My question is, I mean, this clearly involves a lot of expertise in an incredibly broad range of fields. Do you think the next generations of researchers will come from people that are trained in these separate fields that then work collaboratively, or is it possible that universities will start to train people to do some combination of these right from the beginning?
Well, difficult to answer the question whether that's possible, but I think it's definitely necessary. And we see more and more interdisciplinary courses arising, and I think the recognition for the need of interdisciplinary collaboration is really wide. The question is, or the difficulty is really to pull it off.
Thank you very much, Barbara. We're moving to the